Hello. Today we're going to talk about 6.8 graphing radical functions. All right, to graph radical functions, we need to understand that essentially the inverse of a quadratic is similar to a square root function. All right, this really helps us out with rapid graphing. All right, so if we wanted to do the parent function of a quadratic, so if we wanted to graph something with a plus or minus with the square root, it's essentially a sideways parabola. Okay, a square root function is essentially a sideways parabola, but only the top half. Okay, unless there's a negative out front, which flips it and makes it go upside down. All right, but a square root's going to look like this. The inverse is, of course, then going to be flipped and made to go up and be the right side of the parabola, the positive side. And if you notice, the inverse of a function, so if we were to graph this one here, would do something like this, and the inverse of this one goes like this. Well, they cross over y equals x. Okay, well, does that make sense? Why would they cross over y equals x? Because inverses is just flipping your x and y. So of course it would flip over y equals x because that's what we changed in our graph. Okay, so it's just some similarities you want to notice. Now let's graph the parent function, essentially the square root function with no other numbers. If I don't know how to graph it, I can always make a t-chart. So let's plug in something that's easy. Well, can I plug in 4? That's easy. That's 2. Plug in 9, we get 3. Let's see. Plug in 1, we get 1. Let's see. You can plug in things like 7 and 3, but then you get decimals, and I just don't feel like graphing decimals. All right, but we can, just so I can show you how. So for instance, if you plugged in 7 and then the square root of 7 is let's see, 2.645, blah, 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 blah. Well, I can't graph that accurately on here. I don't think you're going to be able to tell the difference. So I'm going to estimate that close enough to 2.6. Okay, so when I go to graph it, I go to 7. So 1, 2, 3, 4, 5, 6, 7. And then I go up past 2, almost like right above 2.5. So above halfway. Now look, can you really tell the difference if I did 0.5, 0.6, or 0.7? No. All right, it's close enough. Okay, when you're graphing, you can do things like that. Okay, it's hard to eyeball it. All right, graph your other ones. We have 4, 2 and 9, 3. We have 1, 1. All right, now notice, all right, this is when I get kids that usually stop. There's another number here. I could have plugged in 0, right? The square root of 0 is just 0. That's the lowest my x can be, because if you think about it, think about your domain here. Anything underneath the absolute value has to be greater than or equal to 0. So the smallest thing you want to plug in is 0. Okay, that's your limit. That's your domain. It goes from 0 to infinity. So we finish off our curve. We try to hit every point and put a little arrow at this side. If you put an arrow here, I will mark that wrong. That is as far as to the left it's going. All right, now let's graph this one. Ooh, sorry, that radical really messed up there, but that's all right. We can graph it using rapid graphing, or we can just make a table. So let's use the same color. So here, x and y. So think about your domain. Domain says anything underneath the radical has to be greater than or equal to 0. So x has to be greater than or equal to -3. So that is the smallest thing I'm plugging in. I plug in -3. I get -2. right? Negative 3 plus 3 is 0. Square root of 0 is negative 2. All right, then just start plugging in everything else above negative 3. Negative 2, negative 1, 0, 1, 2, right? If you don't know what's going to make it a nice radical, just plug stuff in. So let's see, we get 1, let's see, negative 1. We get this, the square root of 2. This is going to be gross. Square root of 2 minus 2 is negative 0.6. You plug in 0. So we get square root of 3 minus 2. We get negative 0.3. Ooh, another gross one. Plug in 1. Ooh, this would be nice. That's just going to get you 0. Plug in 2. We get square root of 5 minus 2, which is 0.2. We graph those, negative 3, negative 2, negative 2, negative 1, negative 1, that one's gross, but 1, 0 is nice. Okay. Oh, that's not 1, 0, that's 1, 1. 1, 0. So notice what's happening here. Slope of 1, slope of 1/3. Oh, look at that. Slope of 1, slope of 1/3, slope of 1/5 to the next nice one. So it's like a sideways parabola. So it's going to do the rule of odds. As long as nothing's out front, as long as you're not multiplying by a number, it's not a 3 out here or a 7x, you can follow this 1, 3, 5 rule. All right, that's what I love about rapid graphing. Okay, so you can notice things like this. You can also point out directions. Okay, the plus 3 also meant that it's going left 3. The negative 2 means it's going down 2. Remember we did this with absolute value. We also did this with quadratics. And now we can do it with square roots. So the h and the k are going to tell you where that origin, that 0, 0, moves to. So this went left 3, down 2. That's where we shifted our graph. So if you want to do rapid graphing, you better tell me this. That's how you show your work. If you don't like rapid graphing, then just make a table. All right, so why don't you guys pause, try this one, use a table. If you want to do rapid graphing, notice that the 0 point, 0, 0, only moves to the, moves up 1. Now, in a regular function, so in a quadratic, if you were to multiply by 2, you would just multiply the slopes by whatever a was. Well, our slopes now follow the pattern of 1 over 1, then 1/3, 1/5, 1/7, and so on. So now with a new value of 2, 2m would be 2 over 1, 2 over 3, 2 over 5, 2 over 7, and so on. So the slope would mean the next point is here, the next point is here, and then here. So your graph should look like this. If you did a table, your table would have the following values. So 1, 3, let's see, 4, 5, and 9, 7. All right, let's try another one. With rapid graphing, you would see that the 4 tells you to go left 4. The 5 tells you to go down that many. And then the negative means it reflects, right? Hopefully you remember that. So first let's move the left 4 and down 5. So left 4 and down 5. So our slopes are now going to turn into negatives. Okay, so negative m, so that would be negative 1 over 1, negative, negative 1 over 3, negative 1 over 5. It's always over the odds. Okay, so we go down 1 over 1, down 1 over 3, down 1 over 5, down 1 over 7. I run out of room, and we go this way. That's with rapid graphing. The table, that looks gross, but that's fine, would be, oh goodness, 4, 5. Oh, I'm sorry, negative 4, 5. Then negative 3, 6, 0, 7, and that's going to be an 8. Is that 1, 2, 3, 4, 5? Yeah. All right, and then numbers in between. Okay, your lowest value should be negative 4, though. All right, so let's also do cube roots while we're at it. Okay, so if we do the same thing as before and we make a table, right, because we have no idea what this looks like, plug in stuff. Well, I can do the cube root of 0, right? Cube root of 0 is 0. Cube root of 1 is 1. Let's pick something nice. So cube root of 8 is 2, right? 2 cubed is 8. Might be easier to go that way. 3 cubed is 9. We go up to 4, well then it's really big and that's going to be gross. Okay, that's going to be, what, 64? I don't want to graph that. So let's see, can we go the other direction? Can we plug in a negative 1 for x? Okay, well, negative 1 is just negative 1, right? Think about it. Negative 1 cubed is equal to negative 1. So therefore, we can move that over and say the cube root of negative 1 equals negative 1. Okay, hopefully you remember that. Okay, I also know that the cube root of, let's see, negative 8 is negative 2, and negative 9. What am I doing with 9? 9 is not 3. So silly. Man, this is why I wish I was in class, so you guys could yell at me. 3 cubed is 27, not 9. Ew, I don't want to graph that either. That's a large number. Ugh, throw that out. So back to what I'm doing. Yeah, I don't want to throw in anything else because now it's too large. Let's graph it. 0, 0, 1, 1, 8. Let's see, 4, 6, 8, 2, and negative 1, negative 1, 3, 4, 5, 6, 7, 8. Well, oops. There. All right, and what's going to happen is it's going to make this little S-curve. So I kind of do it like a sideways parabola there, and then I do another sideways parabola. Ooh, a little too large. Okay, I know your line may not go exactly to the point. It's fine as long as you've got your points and they're clearly labeled. I know you were trying. Okay, get it roughly in this like little kind of S shape or curve, whatever you want to call it. All right, so let's try this one again. All right, now I know a lot of kids like the tables, so I'm going to do this one with tables first, and then I'll do the next one rapid graphing and then show the table what you should have gotten. Okay, so as a table, we know that 0 is the smallest this cube root's ever going to be. So make x minus 3 equal 0, and that gets you your starting point. You know you're going to be at 3, well 3 comma 2 if you know your h and your k's, right? Which is really super useful. So that's where your starting point is. So plug in 3 for x, you're going to get 2 for y. Now then you want to plug in numbers around it. Okay, so actually let's put 3 comma 2 in the middle. You want to go 1 up and 1 down, right? It's pretty useful. What am I doing? That's a 2. You could keep going if you're trying to get exact numbers. I mean, it really depends on if you have an A value or not, on whether or not it follows a pattern. Okay, so you can just pick values that work. Okay, well, why don't we just do it? as 1 and 5. So if we plug these values in, let's see, we get plug in 2, -1, we get 1, plug in 4, we should get 3. That makes sense. Plug in 1, hold on, let me get my cube root. Cube root of 1 minus 3 plus 2. So we get 0.74, so just 0.7 is fine. We plug in 5. We get 3.3. Okay, so let's see what this looks like. So 1.7, 2, 1. Here we go, 5, 3, 3. So we're starting to get that S shape, but let's go a little bit further out. So maybe try 9 and, -9, just so you can get both sides of your graph. Honestly, this is what I would do. I would just plug it in, see what happens. So if we plug in 9, we should get 3.8. If we plug in -9, we get -0.3. So -9 is -0.3, and 9 is 3.8. Ooh, that doesn't make sense. 9. Did I not graph this one right? What did I do? 5 is 3.3. Ah, I didn't graph that one right. Grab the eraser, hold on. 3.3. Okay, and then this one is 9 is at 3.8. So, yeah, it should take a while for it to go anywhere, right? Unless it's got a big A value, all right? Or an A value, that's going to manipulate it. Okay, so for rapid graphing here, all right, we should just know that that goes right 3, and that's up 2. So right 3, up 2, and then it just follows a pattern of 1, 1. Okay, so that slope is 1, and then you go the other direction, which is -1. Well, I guess 1 and 1, right? That's all the same slope. I don't know why I'm being silly. 1 to the left, 1 to the right is what I'm trying to say. And then the next one, you go over 5. No, that's not right. That's silly me. It's, we missed it. It's 8. Hold on. See, it's right here. So see how it goes 1 there, and then here, 3, 6, 7. Well, silly me. Okay, 7. Oh, I guess it was from 8 from the beginning. There you go. 1 and then 8. That makes sense. 0, 1, 8 is your X values. Okay, so 0 from, 1, 1 from the original, and then go 7 from that one. All right, so rapid graphing with this one, we would go left 2, down 4. We know it would have a reflection, and our slopes would be, well, it was 1 over 1, and then, let's see, would that work? Let's see. That would be 1 over 7. So let's try it. Okay, we know the original point is going to be -2, -4, right? That's my middle part. So if I wanted to do this with a table, I know that would be the middle. -2, -4, and I would always go around it. So let's do -1 and -3, which I'm predicting. All right, so now it's going to go down, should be here and here. So let's see, if we plug in -3. All right, when you plug in, when you plug in -1, you should get -6. And when you plug in -3, you get -2. So yep, my slope rule is working here. Perfect. All right, so then that means the next one, we should go up to over 7. 1, 2, 3, 4, 5, 6, 7. So I'm predicting that when I plug in negative 10, I get negative 8, negative 2, 4. Yep, I get 0. Perfect. And then here, 1, 2, 3, 4, 5, 6, 7. I'm predicting this one. So that's at 3, 6. 1, 2, 3, 6, 8. So that's at 6, 8, which makes sense. That's a jump of 7. If you plug in 6, 8, 2, negative 4, oh, negative 8. Oh, yep, which is actually what I graphed. I just didn't write that. So here we get a larger S shape. So understand your transformations. Okay, it's really going to help you out here. All right, if you have any questions, come see me in class.